Vehicle shock absorbing is a process or mechanism of reducing the impact of up and down or lateral movement of the vehicle suspension as the vehicle moves over an uneven road or through potholes, humps, and bumps. The objective of shock absorbing is to achieve a ride control of a vehicle in motion. Shock absorbers reduce the effect of traveling over rough ground, leading to improved ride quality and better vehicle handling. What is a shock absorber? A shock absorber, also known as a shock damper, is a mechanical or hydraulic device designed to absorb and damp shock pulses. It achieves this feat by converting the kinetic energy of the shock into another form of energy, typically heat, which then dissipates into the atmosphere. Most shock absorbers are a form of dashpot, a damper which resists motion via viscous friction. Pneumatic and hydraulic shock absorbers are used in conjunction with cushions and springs. The biggest consideration when designing or choosing shock absorbers is where the energy will go. In most shock absorbers, energy is converted into heat that heats up the hydraulic fluid in a hydraulic or air in air cylinders. The heat energy is then exhausted into the atmosphere. In electromagnetic shocks, the dissipated energy can be stored and used later. Vehicles typically employ both hydraulic shock absorbers and springs or torsion bars. In this combination, shock absorber refers specifically to the hydraulic piston that absorbs and dissipates vibration. Special features include: some shock absorbers allow timing of the ride through control of the valve by a manual adjustment provided on the shock absorber. In high-end vehicles, the valves may be remotely adjustable, offering the driver control of the ride at will while the vehicle is being operated, like height adjustment. Additional control can be provided by dynamic valve control in response to sensors, giving both a smooth ride and a firm suspension when needed, allowing ride height adjustment. Ride height control is especially desirable in highway vehicles intended for occasional rough road use as a means of improving handling and reducing aerodynamic drag by lowering the vehicle when operating on improved high-speed roads. STROBE, the ultimate gas shock absorber. When to change shock absorbers. Like all other car components, continuous use that shocks are subjected to during driving causes wear and tear, and they lose their ability to function properly. The following are some of the telltale signs that your shock absorbers need replacement. Increased braking distance. Worn out shock absorbers increase the braking distance by up to 20%. As traveling speed increases, the braking distance increases. Swerving and nosediving. A vehicle that dips or swerves under braking requires immediate change of shocks. Dipping and swerving under braking conditions decreases your control over the vehicle and can be dangerous in wet weather. Vibrations. When you get vibrations through the steering wheel as you drive, means that shock absorbers are worn out and need replacement. When shock absorbers are functioning properly, they keep tires in optimal contact with the road, and there should be no vibrations. At high speed, vibrations can be more intense and decreases overall control of the vehicle. Car sliding and veering. Car sliding or veering in mild winds is a telltale sign of worn shocks and can be easily fixed with shock replacement. Rocking and rattling. If a vehicle rattles and rocks over bumps, railway tracks and uneven surfaces, it is a sure pointer to heavily worn shocks. In addition to an unpleasant ride, this rocking and rattling puts unwanted pressure on other car components, and therefore shocks should urgently be replaced. Uneven tire wear. Bald patches or uneven tires mean that tires do not have optimal contact with the road, which is directly related to worn shocks. It affects both car ride control and tire grip. STROBE, the ultimate gas shock absorber. How the shock absorber works. STROBE utilizes high-quality Mitsubishi oil in conjunction with nitrogen gas which cannot retain heat, thus increasing the lifespan of the O-rings within the shock absorber. Movement of the suspension is transferred by a piston in a pressure tube, the shock absorber. The piston works its way up and down the pressure tube by compressing and displacing oil or gas in the pressure tube, forcing it through very tiny holes, orifices, which in the process builds resistance against movement, thereby slowing down the movement. Resisted kinetic energy is transformed into heat energy that is dissipated into the atmosphere. Warning: not all shocks are good shocks. Don't shock yourself or your car by fitting bad shocks. STROBE, the ultimate gas shock absorber.